Hi, myself Polish. Today I will going to discuss here the machine learning problem for interchanges of week 5 of exercise 4. So it is the assignment. So you will get the assignment from here. Now directly I'm going to the main part because my the video will be very lengthy. So before going to the exercise, I will suggest you there is a PDF file to how to solve and how to modify the functions. Okay, all the things given detail. So read it very properly and watch the video and make it. Then you will get the more clarifications inside. So it is the main code of export.n and all others are the function. So you don't need to change the main code. Only you should have to change the function. Where's the requirement is. Now take a look at the left hand side. In the left hand side they are given two mat files. X4 data 1 is the input data and X4 weight, it is the weight of the inputs. So let's start it with that. Here I'm keeping track of input layer size is 400 and hidden layer size is 25. I mean number of hidden layer and number of level is the output. There is 10 type of outputs, digits, numerical digits for 0 to 9, and loading and visualizations data in this part is happening. So I'm giving the message that is the loading and visualizations data part. What happened in this part, I'm doing that it is the export data one. I'm importing the input data and input data size is 5000. 5000 instances is there. I mean number of inputs is there, and cell is what happened in this form. This cell is randomly shuffling the values of x and the inputs. After that, from the shuffling, it is takes the 1 to 100 input values is and it is display the result. So go to the display result functions. How it is displayed? It is displaying is again like that way, and it is code is given already. This code is no need to modify. Already they give these codes and there is no need of modifications. Just your purpose or clarification, you can see and take a look of this code. By the way, come back to the main code. Now here it is the program post. If you want to go further, then press enter. So it is the loading parameters. Loading parameters already they given the parameters in the mat form of ex4 with not mat. So first what happened, I am importing the parameters. Now I am taking the parameters as a matrix forms theta 1 and theta 2. I'm taking this theta 1 theta 2 as a matrix form. Now I'm computing the cost of forward propagation. Take it carefully, very low. When you compute the cost, we will compute the cost with the regularization term. Okay, very carefully. We will compute the cost with the regularization term. First, what happened? We will compute the cost without regularization term. Without regularization term, means regularization theta values. Sorry, not theta values. The lambda values actually it is 0, so it is no regularization. That time we will calculating the cost values. The cost values is taken in the calculated by this function of init cost function, where it takes the argument init parameter input layer, hidden layer size, number of level x, y, and lambda values. So let's go to the init function and let's see how it is working. This cost function is given here. How it is the cost function is working? This part is completely given to your codes, no need of modifications here. You will just modify the code from here in this section. So what happened? You should have to calculate first each of the here made signal values, and made signal values will be activated with the function any activation function. So why we are adding these things? Because it is the bias values we are adding with each input. Now the input values is multiplying with the theta's values and y values, and it is naming as J2 values, and J2 values is now activated with the sigmoid function. Sigmoid function it is activated the signal. So how it is activated the sigmoid functions? Go to the sigmoid function and let's see how it is activated. Sigmoid function is very easy. You know already that g is equal to 1 by 1 plus e to the power of minus z. It is the signal function that I already discussed this thing. So come here. Okay, it is for the layer 1 and it is we are doing for the another layer. So after that, what happened? Why new? Why new is the new output. The new output first is 0. So what happened for each of the layer new output will be there something. So it is one in for number of instance or number of inputs. It have different values of output. So we are storing these values of output by new by I like this way. First, now we are calculating the jth value and the cost value. Cost value we will calculate with the regularization. Remember, so it is the cost values you already know regularized. Sorry, logistic regressions cost value is logistic regressions cost value. So with the logistic regression cost value, we will apply another functions, another terms. The right hand side is known as a regularization term. Before calculating the regularization term, we should have to calculate the values of T1 and T2. What is T1 and T2? It is the theta values, particularly theta's values we are taking. After that, we are calculating the regularization term. Our usual is regularization, and the regularization term is calculating here. Now we are adding the regularization term with the cost function. So in the whole thing you can do with one line also. First you will declare these things the above anywhere, above in the part anywhere. After that you can merge the regularizations that term with the cost function here after adding class values. So it is the node you can start here. Now we will calculate the backpropagations. Now the signal to will become from the output layer to input layer. This part is very important. I will suggest you to watch the video 2 to 3 times to make a note how this works actually. So we want is the input values and it is the values of the output layer and E1 taken as a transform and J2 is the theta 1 into A1 we are taking and A2 is equal to sigma of J2. Like this way in the back propagation and it backward we are calculating the signals for each of the steps and steps 2 is what we will sorry it is sorry and little bit it is the forward propagations we are doing for each of the input layers. After that what happened we are calculating the error of each of the layer. So it is the last layer of suppose delta 3 is layer 3. So layer 3 have its predicted output minus actual output, so it will have some error. This error is now will be distributed to backpropagation. How? So error will be distributed from delta 3 layer 3 to layer 2, and the layer 2 how the error will be distributed is given by an equation. This is already discussed in this video. Please be sure and take a look at the video again how it is working. Okay, it is the short form, but it have explanation. Step 4 is so we will do the calculation again for the second layer, but not for the first layer. Why? In the first layer only input values is there, so no need to calculation to the error of the first layer because in the first layer there is only input. So in the first layer there is no error. So delta underscore 1 is no need to calculation. Now in this part, what happened? Theta 2 gradient is each of the theta have a gradient value and along with that we are adding one more thing the error from we are adding and the signal which is coming from its next layer. The signals values transformations we are taking and we are calculating the that layers the gradient value. Okay, that layer gradient value and this is the end of the thing. Now what happens in the fifth stage you should have to calculate the gradient of that gradient of the theta value. So gradient of the theta value just to add 1 by n and the theta to grad this thing for first layer as well as in the second layer. Up to here this part is complete. Now what happened theta 1 gradient or except the sorry, bias values we are calculating, and it is theta 1 gradient value, and then with that we are adding this term. This is the regularization term we are adding for theta 1 grad and theta 2 grad also we are calculating at the same. After that we are unroll the gradient. Unroll the gradients means because it is firstly vector form, now we are taking this thing gradient as a matrix form as a grad. The matrix form is given here. So like this way any cost, I mean numerator cost function is calculated. Now go to the main function again. In the main function, when you calculate the gradient and cost values, now we are showing it. If the total means here the gradient, sorry, cost function value will be here, and our cost function value we will print in here in J, and we'll pause it, and if you want to proceed the video, then press enter. Implementation regularization. Regularizations will implement in now. This part is same. This part, implementation regularization parts considers the very same of like that. But the main difference is here. We are taking that lambda, I mean without regularizations, we are taking, I mean lambda as a taking 0. So next part, when the implementing the regularizations, we will not consider lambda value as 0. Now we will consider the lambda value as 1. And the concept is very similar to the previous one. Now going to the sigmoid gradient. What happened in the sigmoid gradient? That G is calculating the sigmoid gradient values for the values of 1 minus 0.5, 0 and 0.5 and 1.5 values it is calculating. Let's go to the sigmoid gradient and let's see how it is working. Sigmoid gradient is here, and the sigmoid gradient is given in short form like this. This just sit. It is the activated signal. An activated signal, I mean it is the like a into 1 minus a. I think he is describing this thing in theory. Okay, this thing is similar. Come back to the main function. So when this part is calculating, so sigma function value, they are showing that sigma function value will be shown by the notation of G here, and it will takes the main line. After that, the program will be paused for the moment. If you want to proceed with enter. Now initial theta, I mean the weight values we are taking, and randomly initializations weight. From there, randomly initializations weight, it is the function, it is randomly, it is given already. You know, to need to modify. Sorry, little modification is needed here. Just how it is happening. This thing already discussed. Why you need this thing? Random initializations of weight, because to get the more precision values and more accurate output, you need to give some random value of the weight, okay, instead of a blank value. And when you gradient it, so gradient it in both way, that's why they're taking an epsilon value as small value 0.12, can be any other value, no problem. So it will makes the gradient more accurate. Both side derivatives makes the gradient more accurate. For that reason we are taking this one. Come to the next parts. This thing is uh, uh, this operations is will do for the initial theta 1 and the weight values of theta 1 and weight values of theta 2, layer 1 and layer 2. And uncontrolling parameters is what? Uncontrolling parameters is that we are saving this weight values, I mean initial theta 1 and initial theta 2 as a matrix form. And the matrix forms the notations stored in the values is here, the variable. Now implementation of backpropagations here. The implementation backpropagations, how we will do it is check gradient descent, we'll taking care of that. So check gradient descent already is given here. So you no need to modify any code in the check gradient descent. Let's see. The code is already given here. Okay, this code is a little bit complicated, but you don't need to modify anything. should be check gradient descent. Take care of this subject gradient, back implementation of gradient descent, how it is work in the back end. The code is implementation of the regularizations. When we implement the regularizations, again I'm considering the lambda's value as now as 3. We want to debug lambda. I mean debug lambda means we are debugging the cost functions values is now again in the similar manner of like previous, and it will give something different values, and different values is shown in the debug underscore g values. So now this is the testing form, and the testing option is going to optim sets. This how it works. To more understand, I will suggest you go to the MATLAB help line and you will type here help optim set. You will get more accuracy about that. Either into MATLAB documentations you will get the more details about optim set. Neither if I discuss this thing here, it will be very lengthy video. Now creating shorthand and cost function to be minimized. So cost functions with the argument of p and cost functions cost function functions with taking the argument of like this way, it will calculating the enamed parameters value as well as cost functions values. And we are doing the operation with theta 1 and theta 2. What happened to the shift? We need to do the reshift. What the meaningful of that reshift is actually what happened. It is converting the matrix representations of theta values to the vector representation again. So you will, it is very well, I mean very wide manners and very nice way to is the video. I will suggest you to go to the video and take care of that and listen it how it works. So the program is paused now, and to see the weight values, what happened to displaying the theta values weight, because we are uncontrolling the parameters we're doing here before, because the theta was previously taken as a matrix form. Now the theta we are taking as a now vector form. Now we are displaying the theta values. What is the theta values? Okay, here, and implementation predicted theta 1 and theta values. What will be the theta 1 theta values? It will be show here, and along with the x, what will be the x and the values. That was the values. So okay, fine. Let's go and run the program. It is working properly or not. Before that, check all the functions. And if you want check gradient, this is the one check gradient. This function is already this function is already given to you, and no need to modify these functions. Next function is compute numerical gradient. This function also given to you, and no need of modification here. Display data with this function also given to you, and you no need to modify this function here also. It is the main code, no need of modifications here. And if make cheap, it is also the functions. In these functions they are also given, and no need of modifications here also. But you need to use that function in init cost function that is given. You need to modify that functions in a nice manner, in a meaningful way. Your code will be starting from here. So each of the layer will first calculate the strength values. Now it will calculate up to the output here. Now calculate for the output, and it will differentiate. And what happened? The J will calculate regularized logistic regression, regularized logistic J value and cost function value we will find here. After that, we will do the backpropagation operations each of the layer, and yeah, step by step, and we'll do the operations of the theta, one gradients, and regularizations we will use as here also. For both conditions, when jth values is greater than equals, for that values we will apply. And predict is the function that is given, and this code is given to you, and no data modification here. Random initialization is this code is given to you, and you need to modify only this one. I mean it is the both derivatives that concept. And sigma radio is the one line code which is already given to you. So let's go to the main function and run the code. So in the MATLAB, nothing. So press x4.m. So x4.m. So it's loading visualization return this one. Let's enter. So it's showing the values will be here like that way. Cost function value, and we are getting the cost function values like that. Very similar, not very similar, exactly similar. Taking gradient value will be 0.33770. Our gradient value also the same. So evaluating the signal gradient will be for each of the values the given is here. Now proceed and relative difference, I mean the backpropagation difference, I mean errors. The layer is 2.38 into e to the power minus 1 11. So let's proceed the training. Okay, and the lambda's values given here and cost functions values is here. And let's go to the training for 50 on time iterations. The cost functions each of the time using the back propagation we will decrease the cost function. Let me complete that one. One more thing, for code purpose, we'll search Polish model 351 in GitHub. I think very soon I will upload the code. And I will request guys, please like my video, subscribe my channel and share my videos because it's make me motivate to upload this type of video, educational video. So it's actually inspiring. Okay, that process is completed. Let's enter. So it's the visualization user networks. See the visualization is happening, how the digital reaches and from the various classes. And we got the accuracy of 94%. That's all fine. So submit it here. Okay, I do want my last password or not. Talking to you now. So yeah, I want to click it. Press enter. Okay, alright. Other things update. So thank you for watching. Please subscribe, like my videos, and press the bell icon to get more update. And for code purpose, I will suggest you very soon. I will upload this code in my GitHub repository of username Model 351. Thank you. Have a nice day.